All right, back for episode number 3 for the Core Dev Corner. This is uh, part 2 in a 3-part series where we're going to be talking about testing and hardening. So last time we met, we talked about POX4 testing and also the 2.5 readiness with Bryce and Jesus. Today, we're going to be speaking with a resident from the Stacks Foundation, Nikos, and a contractor with the Stacks Foundation, Bowtie Radwan. Nikos, Radwan, could I get you to introduce yourself real quick?
Sure. My name is Nikos Baksevanis. I've been contributing to testing tools for about 10 years. And the last couple of years, we've been working on property-based testing tools. And the interesting thing that we started seeing is that interesting communities from Ethereum started using those tools to fuzz smart contracts. So we extracted a pattern from there, and we are now applying these for testing smart contracts written in Clarity. So that's what I'm been working on for a while.
Very cool. And Radwan, so you're part of a group of people that we work with from Eastern Europe, the Bowtie community, the Stacks Degen community. That's how I first met you. Could you introduce yourself a bit?
Yeah, exactly. Thank you, Will. So as you said, my blockchain experience began some years ago when I joined Degen Lab. And there we were focused on blockchain quality. First, we started with GameFi, which was nice in the beginning, but then we hopped to the serious stuff and we started DeFi. And we managed to deliver strong projects like the decentralized staking pool, which is the one I'm proud of and is now live. And during this blockchain process, I realized that the most important thing here is the security. So when talking about security, you talk about testing. And this is how I got to Stacks. All the guys here make amazing things for the community. And as a community member, it was like a dream came true and get to working along with Nikos on fast testing Clarity smart contracts for Stacks.
That's great.
That's me.
So we're going to kind of work through 3 different sections of testing. So we're going to first talk about automated testing, and then fuzz testing and invariant testing. So if either one of you wants to jump in, let's first just start very high level. Like what is automated testing and why do we need it within the context of the Stacks community?
So in general, the reason we test our code is to get an additional feedback. Like, yes, we have something that type checks, we have something that compiles. And in addition to that, we need an automated way to verify that under certain conditions that we specify, it will behave as it should. So in a way, we write tests if we say that compilation is a feedback mechanism, tests amplify that feedback mechanism. So the credit for this goes to actually Mark Seaman. He was discussing about this 7-8 years ago. There's a link I could share. And it's actually that we do testing to increase, to amplify the feedback we get from whatever we have before, the compiler or the type checker. Now, there's one more thing. When we publish a smart contract, I'm talking in general and I'm oversimplifying, but when we publish a smart contract on the blockchain, before we were doing that, let's go back to Web 2. if there was a bug, we could easily redeploy things. It's much harder when we deploy a smart contract. It's something like shipping hardware, not exactly, but kind of. So we need stronger testing mechanism there. So
And
yeah,
so when you say it serves as a feedback mechanism, can you kind of elaborate on that a little bit? What types of information are you learning from these tests that you're not learning from the compiler, or just from the normal debugging process that you go through during development?
absolutely. So say that you have a function that adds two numbers. So the function is called add, and you have to pass two numbers. So say you pass 1 and 1, and you expect to get back a number. That's what the compiler can guarantee for you. If you're using a strongly typed language, the compiler will say, yes, this function will return back to you a number. Well, that might not be enough. Is it the correct number? That's when you go and write the test. So in your test, you will say, if I call add and I pass 1 and 1, I should get back 2. If I don't get back 2, it will throw an error. It will notify me somehow that something is wrong. And that's what a unit test is. Many people actually call unit tests example tests, because you just provide an example and you can see that it works as it should. Several years ago, there was a tool written in Haskell. It is called QuickCheck. It's still around and exists, where basically created a new type of testing. You could say, I have my function that is called add and takes two numbers. What if I automatically generate any possible integer? Then the result I would expect would be the addition of those integers. And they call this property-based testing because of the mathematical notion of properties. So in mathematics, you have the domain and codomain, and it comes from academia, Haskell. So again, I'm oversimplifying. So that's how the property testing was born. Instead of providing predefined inputs, you say, that's my function, and I will have generators for those inputs.
And so this sounds like maybe the beginning of automated testing. Is that like one, is that fair? And could you maybe speak to like some of the different types of automated testing that you work with?
So we have the unit example-based testing that we just described. Then we have the property testing, which is you should generate the inputs, and then you start being more generic, and you also test edge cases. And then because, for example, when you add two numbers, it could be that in the function, for whatever reason, you say that if the numbers are more than 1,000, just return 0. And it's not easy to catch this with a unit test. But with a property-based testing, because the input can be wide, it's easier, more likely that you can catch edge cases. Now, some people confuse or mix property-based testing with fuzzing. It's totally different. If we would like to fuzz the add function that I just described, we would say that for every possible input, it should not crash. It should not consume all the memory of the machine. So that's the difference with fuzzing.
And so before
Yeah.
jumping to fuzzing, I've heard you also mention stateless and stateful testing. Is that a precursor to fuzzing, or and are more closely related to automated testing?
So it can apply to both.
Okay.
Sometimes it's called system under test in general. So let's name the add function system under test. Sometimes it's not enough to just test the add function. Maybe you're testing something more complex, where the add function relies on something that another function did. You have state. In order to test that, you need to also keep track locally of the state and compare the state you have locally tracked with what you have with the actual state. So they call this stateful testing for this reason. You're testing, but you are also making sure that all the other things work as they should as you test this one thing.
Right. And so, Radu, I heard you mention earlier, like working on DeFi projects, and I'm guessing that within the context of DeFi projects, state could apply to account balances, transactions,
Yeah,
things of that nature. Is that sort of the main territory that we're interested in?
yeah, sure. So basically, the state you are testing is the internal state of the smart contract in the blockchain project. So, for example, when testing a contract, we can have there three functions. If we were to test stateless, we were testing each function once, and we were starting before each function. We were starting from scratch. At the opposite, when testing stateful, we are interested in the chaining of the operations. So let's say, for example, what happens if we call the increment function after the decrement functions, the decrement function. So there we also keep the chaining of the operations, and we evaluate how the state is modified through that process.
So I'm already beginning to get a sense of like how quickly this can compound and the number of permutations that you are all of a sudden needing to account for and consider. So I don't know, I'm trying to find help me understand where fuzz testing like differentiates from just more like automated testing. I'm guessing that it has limits, and is fuzz testing like I guess a step in the evolution of automated testing, or how would you typify fuzz testing?
Basically, what is cool about fuzz testing is that the only rule of fuzz testing is that there are no rules. So when you fuzz, when you fuzz, you always expect the actual, so the result to be the expected one. So no matter the chaining of the operations I mentioned above, that condition should evaluate to the same expected value. So yes, of course, fuzzing is a step of evolution, because you start from unit tests, then you go to property-based tests, and when you get to fuzzing, you don't know what can happen there. So the human mind couldn't generate that or that complexity of chaining that you test through fuzz testing.
And so, Nikos, you made an interesting observation early on, like you saw some work occurring in the Ethereum community, fuzz testing on Solidity contracts. Like, is testing smart contracts, is that the genesis of fuzz testing, or did fuzz testing come from another part of, was it being utilized for other reasoning, and then it was applied to smart contracting?
So it's interesting because when they talk about, at least on Ethereum, when they talk about fuzzing smart contract, they essentially they mean randomly execution of any function that the smart contract has in order to try to break the invariance. So for example, you can have a contract that's called counter. It keeps the current count as a variable, then it has a function to increment, decrement, I don't know. And they would find a sequence that is so special that when you call decrement 500 times and increment, I don't know, 2 million times, something very bad will happen, like the internal state might reset to 0. Again, I'm oversimplifying, even though we do have an example about such a counter in Clarity we could present if we have time. So that's what fuzzing in smart contract usually, when they say fuzzing a piece of Clarity code or a piece of Solidity code, it's more or less like that. Instead of just calling one function, they will try to call everything on the smart contract. And maybe we can, there's a very nice diagram that we can show if you have it there, or I can.
Yeah,
share.
I've got it right here.
Exactly. That's exactly what when someone says I'm doing fuzzing on a smart contract, this should be always included. So on one side, the big so we have the smart contract and we have some operations L1, L2, and L3 that could be increment, decrement on our counter example. So you have a mechanism, a tool that randomly calls those functions. And then on the left side, you keep track of what's happening. And you always compare what you have kept track with what's returned from the contract. And that's how you can find bugs. That's how you find bugs, guaranteed. It's one of the ways that you can test the whole thing. We actually did that to test POX4. And if Radu wants to share the screen, we can have a small taste of how this actually looks like. We can see real calls being made, and I think it's going to be pretty cool.
Let's
And
do
what's the best part is that in order to do that, we used simple tools. We didn't reinvent anything. We made advanced use of Clarinet, advanced use of property-based testing, fast check, but we didn't have to write something from scratch that could take several months of work. So better share the output.
Yeah.
So
okay.
Yeah.
So here, what you can see, or what you will see, is how the smart contract fuzzing, or what we call smart contract fuzzing, happens. So here you can see that random sequence of commands we talked about, and you can see there are a lot. Basically, we can guide how many calls do we want to have by accessing or setting some configuration variables in our Clarity fuzzer. But you can see here, the first function that was called was a function that basically checks the staking minimum and updates the state with that value, so that we know that, okay, the POX4 contract has a calculated USDX threshold, and then we can perform other operations.
So it looks like
Here's
you're...
the whole chaining.
Go ahead, sorry.
And here we can see the whole execution that happened and what were the results. So here we can see each method and how many times was it called. So the allow contract caller was called 30 times. But let's look at stack STX. This is the most important, or one of the most important functions inside POX4. It was called 3 times. And here we had some unhappy path hit that we expect an error to happen because the state is not what we are waiting for the function to be executed. And to clarify this a little bit, this is how a command looks like. So this is the command for performing a stack STX call using a signature. And
So
basically
when you
a
go through
class.
and when you go through a process like this, how are you, I guess, convinced or feeling confident that you've tested all of the, like, an appropriate amount of permutations or variations of the contract calls to make sure that you have sort of like an appropriate level of test coverage, I guess?
yeah, I got that. So basically, it's never enough.
It's
So
never
the more you test and the more you run, the bigger the chance is to find something. This is why, for example, this whole POX for stateful property testing or POX for fuzzing is meant to be run 24/7. When we run it 24/7, we know that every day it can get vulnerabilities. It already got 2 bugs in POX4, which were minor because POX4 is a beta tested contract and it's really hard to find bugs in a contract as tested as POX4. And along the way, it also got a bug in Clarinet, the tool.
Very cool. So we've got
I hope
about
I didn't lose you.
Oh, no, that's great.
Okay.
So the last form of testing that I know we wanted to take a few minutes to talk about was invariant testing. How's that just, distinctly different from fuzz testing and also applied to smart contracts?
Basically,
So go ahead.
basically, invariant testing should happen if we test inside the Clarity smart contract. We know that in the smart contracts, there are some invariants. For example, a variable shouldn't have a value greater than something we know about. That is an invariant. Here we have some invariants that we mix with property testing, and this generates that random sequence that we, or not only us, but everyone in the blockchain calls smart contract fuzzy.
Exactly. So this is invariant testing, but it's the term is, they either say fuzz testing, the correct term is invariant testing. But as Radu very well said, we mix also other techniques, so we further randomize everything. If you go back and show that class, Radu.
Sure, 1 second.
So the any inputs in that class, we use generators from property-based testing. We don't hard code anything. Everything is random.
For example,
so
a generator looks like this. So for the generators, we decided to use the fast check library. Nikos also knows the creator and has a lot of archives with conversations with them. So yeah. Here, for example, for the wallet, we are picking a constant from a list of wallets that we also have. So we don't even pick or cherry pick the wallet that calls the function. For the authorization ID, for example, we can have any natural number for the period because we are testing the happy path. So the call should happen successfully. We pick an integer between 1 and 12. Why? Because when you stack STX, you can stack for maximum 12 cycles. This is how the values are generated. Then we go to the stack STX that I was showing before. We take that values, as you can see here, and then we make use of them. But before making use of them, we have a check. This check basically checks that the function can be executed, but this is the unhappy path. So here's the happy path. Here you can see that the check function verifies that, okay, does the POX4 contract that we are testing have a staking minimum set? Yes, okay, go on. Then is the staker staking? Because he could not stack if he would be staking. So we expect the negative. We expect the staker to not be staking. And also we expect the staker to not be delegating. And then if the whole condition is true, we can get to the command execution where the magic happens. Here we create a signature. Here we call the function. And here we expect the, to say so, invariant. So this should be the same calculated amount between these variables anytime we run that stack STX command using a signature.
Very cool.
And then you update the state. Very important.
Sure. So as Nico said, this is the proof that the testing we do is stateful, because we get a state. So here we get the wallet from our model and then update it with what happened before. So we say the wallet now is staking because we had a successful call of stack STX, is taking solo because again it didn't stake through a pool. Then the amount locked is the amount we were expecting. He has an or it has an unlock height and so on. But I think you got it, and I hope I didn't lose you again.
Oh no, it's really cool to see see how these terms and concepts that I'm familiar with just through the UI get interrogated and automated through this testing. So I guess in the last minute that we have, we've got quite a roadmap in front of us for the rest of the year with 3.0, SBTC, Clarity WASM, Clarity upgradability, a lot of things sort of on the horizon. I hear that you all are just like plugging in everywhere. Like, are you going to be applying these testing methodologies to, a lot of that, or, is there areas where this type of testing is more applicable than others within the context of everything that's going to be shipped?
For one, we have a version of what Radus showed that is fewer lines of code, so it requires less setup. That's an improvement, and we will use that to test. For sure, it will be work on SBTC, and after that, we plan to make it even easier, and then, if possible, a reusable package could come out so that anyone building on Clarity and Stacks can use these techniques, because everyone can use it right now. It's just that, as you can see, it requires a lot of code and setup, and you have to go into a lot of details. So we try to, we already have a simplified version, and that's something that could make that easily available to everyone building on Stacks, which means it could be also used by auditing tools and companies. So yeah.
Amazing. Well, this has been really cool. Yeah, I just keep hearing really positive remarks from all the core devs about the value that you're adding through this tooling and these methodologies. And it seems like bleeding edge research. And yeah, it's very cool. And thank you for taking the time to share with us and help educate us on some of these processes.
Pleasure.
Thank you so
Great.
much for the opportunity.
Yeah. Well, thanks all for tuning in. And I think we're going to be speaking with another DGen in a couple of weeks about mutation testing, which will round out the three-part series that we've been doing on testing, and then we'll take it from there. All right. Thanks all. Bye.
Thank you.